Hi, Dr. Bones back again. We were talking about Lewis structures and molecular resonance, hybridization. Wanted to talk now about molecular orbital theory. All right, so we're going to be creating bonding and anti-bonding orbitals. I've got a molecular orbital diagram here. And we're going to play with hydrogen and helium. Hydrogen, each hydrogen atom has a proton and an electron. Helium has 2 electrons, all right? In this case, we're not really so much interested in the protons anymore. We're talking about electronic structure. So it's the electrons we're interested in terms of bonding. I've got my orbital diagram. Here we represent a sigma or bonding orbital. And here I have a sigma star or asterisk and the anti-bonding orbital. Get my pointer here. So again, lower in energy, bonding orbital. Higher in energy, anti-bonding orbital. This is a beautiful theory that seems to work in just about every case you can imagine thus far. And it really started with the Lewis structures and hybridization, and finally molecular orbital theory, and many Nobel Prizes have been won using molecular orbital theory. All right, I've got hydrogen and hydrogen. Each hydrogen has an electron. So we're representing the electron with this little painting sponge. So I've got the electron going in there. It can be either spin up or spin down. As you remember from another lecture, I had the pair of shoes. You put the shoes, one shoe up and one shoe down in the box, so they're spin paired. In this case, we've got 2 hydrogens. Doesn't matter for spin up or spin down. So these electrons can go into the bonding orbital. And of course, hydrogen forms a lovely hydrogen molecule, H2. So here we have our hydrogen molecule. I'm going to put this back. Guess these don't come out as easily as I had hoped. All right, so, and we can put it right in here. So we'll have one spin up and one spin down. We formed our hydrogen molecule, so it's in a bonding orbital. So a bond order of 1, single bond. All right, so that is for hydrogen. If we wanted to dissociate the hydrogen atom, well, we're going to introduce the anti-bonding orbital. All right, so you have to be able to break atoms apart or molecules apart. If you're going to be able to put them together, they have to come apart. This is the concept of bonding and anti-bonding. All right, I'm going to replace the hydrogen with helium. All right, so here we go. Here is my helium. And another helium over here. Helium, each helium has 2 electrons. So let's start anew here. Here I've got my helium. It's got an electron, a spin up, a spin down. Remember, it's a closed s orbital, 1s2. And here's my other helium over here, also 1s2. All right, so one spin up, one spin down. If we wanted to form a helium molecule, a helium dimer, well, then these electrons would have to go into bonding, 2 electrons, and 2 would go into anti-bonding into the anti-bonding orbital. Well, if this is the case, we basically cancel one with the other. So if this goes into bonding, all right, so 2 electrons go into bonding, and if 2 electrons go into anti-bonding, you can see using molecular orbital theory what we see in nature. We see that there is no possibility for the helium dimer. Here we have a bonding orbital. Here we cancel with an anti-bonding orbital. In this case, the bond order is 0, so we don't have a helium dimer. So the molecular orbital theory Starts really simple like this and can be used to form many, many complicated situations. So this was the 1s and 1s, and you can go on to 2s and 3s and introduce p orbitals and d orbitals and so on. So a very useful concept, many a Nobel Prize won using molecular orbital theory. So this is now part of your arsenal of chemistry, molecular orbital theory. I'll see you in the next segment of the Dr. Bones Show. Take care.